In this video, we're going to introduce the topic of calculus, and we're going to look at a part of calculus called differentiation. And we're going to look at it from first principles. So we'll start with gradients, gradient of a straight line, which we already know how to find. And the idea of a gradient is a rate of change. And we already know the formula for the gradient of a straight line, and it's y2 minus y1 divided by x2 minus x1. And we say that that's a constant rate of change because wherever we are along the line, we've always got the same gradient. Now, let's have a look at a curve, and let's have a look at the gradient at different points along the curve. Now, we find the gradient at each point along the curve by looking at the tangent. So I'll write that word down, tangent. And I've got some tangents at various points along the curve here. And we can see that as we go from C to A to B, the gradient changes. So the gradient's getting steeper as we move along. Now, what we want to try and do is find the gradient at this point A. So I've drawn a green tangent line to represent the gradient at that point A. And if I look at the gradient of this chord from A to B, so I'll write that word down, chord, and that's a line joining 2 points along a curve. So if I first of all look at the gradient of the chord from A to B3, and then compare that with the gradient of the chord from A to B2, and then from A to B1, we can see that as we move from B3 to B2 to B1, the gradient of our chord is getting closer and closer and closer to the gradient of the green line. And that's the idea that we're going to look at. So let's have a look at an example. So I've got here the curve y equals x squared, and I want to know what's the gradient of the point where x equals 3. So I'll put in a line there. So that's going to be my tangent line at x is 3, and I want to know what the gradient of this line is. So I'm going to have a look at chords between 3 and different numbers. So I'm going to start off between 3 and 4, or x is 3 and x is 4. I'm going to bring that a little bit closer. So x is 3 to 3.5, and then 3.1, and then 3.01. And I'm gradually going to get closer and closer and closer and look at the gradient in each case. And I'm going to have a look at what happens to that gradient. So let's do that by setting up a spreadsheet. So I've got one here. So I've got my x values in my spreadsheet. So my x1. Let's move the label over to there. So I've got x1. And then I need an x2. So x2 is going to be x1 plus these numbers over here. And to get these numbers, I've just divided the previous one by 10. So if I fill that in, I'm going to be equal to 3 plus this number over here. So that should give me 4. Now if I drag that down, that also drags down the formula. So I've got numbers that are getting closer and closer and closer to 3, but don't quite get there. I then need the difference, so my x2 minus x1. So let's do that. So x2 minus x1. So I'm then going to drag down that formula. I've got my y1. Now y1 will always be 9, and my y2 will be by x2 squared. So remember, my function is y equals x squared. So I'm going to do that as equals to x2 multiplied by x2 again. So if I drag that down, so I've got my y2 values there. And then I need the difference between y1 and y2. So if I go equals this one minus this one. And then if I drag that down, that gives me my differences. So I now need my gradient, which will be my y2 minus y1 divided by my x2 minus x1. So if I do that, y2 minus y1 divided by my x2 minus x1. So let's drag that down. Now I think somewhere down here the spreadsheet seems to go wrong a little bit, and I think it's probably because it's running out of decimal places and it doesn't quite understand what I want to do. So I'm just going to delete those ones there. So we seem to have got a good run of numbers up to this point here. So can we see what's happening to the gradient? So we start off with a gradient of 7, then 6.1, 6.01, 6.001, and then 0001. So can we see that we're actually getting closer and closer and closer to a gradient of 6? So we can conclude there that the gradient at x is 3 is 6. So let's write that down. So the gradient gets closer to 6. Now we can also have a look at that on some graphing software. So I've got it set up here with my y equals x squared, and I've got the point x is 3 here, and then x is 4 here. So I'm just going to highlight that, and then we can see the box there, or the triangle rather, with the chord, and we've got a gradient of 7. Sorry, gradient of 7 here. So if I bring it closer and closer together, so I'm going to move my point here closer to, it's a bit too close, so I shall go back there. So let's bring that point closer. So we can see 3.9 is the x value, and our gradient's gone down to 6.9. So I'm going to get closer and closer and closer. Now I'm getting very small here, so I'm actually going to zoom in. And then I can do that again, so I can bring it closer and closer and closer. And then let's zoom in again. We can get closer and closer. So I'm going to keep getting closer and closer, and I can see my gradient changing there. We're now at 6.1. So I'll go a bit further, and we can come in there. So we got at 6.01 for a gradient. Move it along. And we can still get closer and closer. Now, because of the rounding, I seem to have gone to the gradient of 6, but we can see we're not quite there. But just looking along the x-axis, we're getting to a very, very close to 3 here. So I'll just do that one more time. And as you can see, we could just keep going forever, getting closer and closer and closer, but never actually getting there. And so we're getting closer and closer to a gradient of 6 there. So we'll look in the next video, we'll look at doing what we've done there in a more algebraic way and come up with some general rules of how to find the gradient at various points.